Okay, today we are talking about section 2-1, rational numbers on the number line. And we talked about some ideas of what a rational number is. So now I'm going to tell you, a rational number is a fancy word for a fraction, or a fraction that can be written as a terminating decimal. Okay? So rational numbers are fractions or decimals that have an end, or decimals that repeat the same number over and over. Okay? The other kind of number that we're not talking about today is called irrational number. And irrational numbers are like pi. You know how pi goes on forever, and they've literally never found an end, they've never found anything to repeat, it just goes on forever? You know that? Remember that? So pi is irrational because it doesn't end, it goes on forever. But rational numbers would be like a decimal that's short, like that, 0.25. Or it could be a decimal that repeats 3 forever. Does anybody remember how to write that when a decimal repeats? Yes, very good. The line is a way to write it when it's repeating that number over and over. Okay? Stay near the top, otherwise you're going to get pictures that aren't relevant. Or fractions. Okay, so those are all rational numbers. Okay, I will try to help you find one. Remind me. Okay, so this is just kind of a review. This number line up here, it has our negative numbers, our positive numbers. Of course, it has 0 in the middle. And then it has the different types of rational numbers. So everything that we're looking at right now is all rational numbers. Natural numbers start at 1 and go positive. So it's any number from 1 to the positive end. Whole numbers start at 0 and go positive. So can a whole number be negative? No, because it starts at 0 and goes this way. And then integers are all my numbers, negative, positive, or 0. Okay, and this is just a review. So now if we're looking at page 70 in the book, and I'm going to pause so everyone can get their book, page 70. So number 1 on page 70 says, tell whether the statement is sometimes true, always true, or never true. An integer is a rational number. An integer, that's this one, is a rational number. Is that sometimes true, always true, or never true? Okay. Anybody else?
Wait. Always. Yeah, sometimes.
Always? Sometimes? Anybody else voting? Okay, so remember, these are all rational numbers that I drew for you. So if it's an integer, then it is always a rational number. Good job. Number 2 says, explain the meaning of absolute value. What's the definition of absolute value? You have to think back in your brain. Absolute value, guys. Absolute value is what? What's the absolute value of negative 10?
10.
10. What's the absolute value of negative 320?
320.
Yes, so what does absolute value tell us?
The value without the negative.
Okay, yes, that's one way to describe it. Good. It also tells us how far a number is from what?
0.
Yes, thank you. Good. 0. How far a number is from 0. That's what absolute value is. Number 3. Give an example where absolute values are used in a real life situation. Absolute value. Real life situation.
Absolute. Your attitude.
Your attitude.
And a negative attitude.
Okay. That's good. I'll take it. So like your attitude's -10 today. I need the absolute value of that attitude. Like that?
So you want me to do 10?
Yes.
Oh.
You get it?
Yeah.
Okay. That's good. That works. I can think of situations where we use absolute value in like algebra class, right? Anybody else have ideas? Har. What's that?
I'm laughing.
Oh, okay. All right. Let's move on. Number 4, it says name the coordinates of the points that are graphed on each number line. So we're just looking at the number line and we're telling what points they graph. So who can look at number 4 and tell me what points are graphed? We're going to go least to greatest. Rayleigh.
-2.
Yep.
Then there's 1,
Okay.
2, 3. 2, 5, my bad.
2, 5.
I'm sorry.
That's okay. Okay, yes. And remember, we're going to write with these little solution set bars because we have a set of numbers that are on the same number line. And this tells me I have a set. And I'm going to write them from least to greatest. So that's kind of the easy part, is reading whole numbers that are graphed on a number line. Now we're going to look at some other types of numbers, like fractions and decimals, that are graphed on a number line. So can someone else tell me the numbers that are graphed on number 5?
-11/2.
-11/2.
And then it goes -9/2.
Okay. Rayleigh, let somebody else do the rest, okay? What else? Yep. Keep going. Okay. And yes. Again, I'm going to put my solution set bars and I'm going to separate each number with a comma. Okay, number 6 and 7 and 8 and 9, now it tells us the numbers, the set, and we have to graph them. So that's what we're going to do now. So on each one of these, you have to have a what? If I'm graphing it, what do I have to have?
A graph.
A graph, yeah, a number line. And yes, my number line should have a 0 in it. So before I draw all my numbers though, I'm going to see what my span is in the book, so I don't draw too many numbers. So it looks like I go from, what's my lowest number?
7. 1.
Lowest.
1.
On number 6. -4, and my highest?
7.
Okay, so that means I'm going to have 0 there, and I need to go to 7. Try to make your spaces even. And then I'm going to go -2. I'm going to pause this while we make the number line. Okay, so for graphing these points in number 6, I'm looking at the first one. The first one is -4. So I'm going to find my -4, and I'm going to put a point right on that spot. Your point has to touch your number line and touch the up and down line of the -4. The next number is what?
-2.
-2. So put 1 at -2. The next number is what? 1. And then?
5.
And then?
7.
Okay, so there we go. We just graphed all the points in number 6. So the first number I'm going to plot is -2.8. So I'm going to go to -2, but then I have to go 0.8 more. So it's 0.8 is how far? Is it closer to the 2 or the 3? 3, good. So I'm going to put my 2.8 right here. Now, since my number at the bottom doesn't match the decimal that I'm graphing, I have to write the number I'm graphing up top. So I'm going to write 2.8 at this one, negative. And now I'm graphing what? Negative 1.5, which would be halfway between negative 1 and negative 2. Because it's negative 1 and then 0.5 more. And I'm going to write that above. What's my next one? 0.2. Oh, good. I thought it was just 0. Okay, where is 0.2 on my number line?
There is none. Wait.
There is none, but it would be close to the 0. So I'm going to just go a little bit above 0. And I'm going to label it 0.2. I don't know. Kayla's earning some Starbucks today. And the last one, 3.4. So where would that be?
A little bit before the 3.
Say it again, Ethan. In the middle of 3 and 4. It's a little bit less than 3.5. And we're going to label that with 3.4. Oh, I'm trying to get out of the way. There you go. Okay, so for number 8, we have to graph fractions. Now, the easiest way to graph fractions is to turn the fraction into a decimal first. And then it's going to be super easy to see where exactly that fraction goes on the number line. So the fractions that we have, and I want you to write these down this time too. Negative 1/2, 0, 1/4, 2/5, and 5/3.
I think my sister understood this.
Why?
She took my calculator.
Oh. She owes us both Starbucks. So, the easiest thing that I could do first on this one is graph which number?
0.
Yeah, the 0 is going to be super easy because 0 is just 0. So I can write it like that. The second thing I'm going to do is I'm going to turn every single fraction into a decimal. How do I turn a fraction into a decimal?
Top number dot divide.
What? Divide. And I think that's what you were saying too. So I'm going to divide. Remember, fraction means division. So in your calculator, you could put negative 1 divided by 2. Somebody tell me what it is.
Negative something.
Yep. Come on, it's a race.
Negative 0.5.
Thank you. Negative 0.5. What about 1/4? What does that equal?
1/4.
As a decimal.
1.4.
0.25. How come Ethan's the only one doing it? Come on, people. What is 2 divided by 5?
3.4.
Thank you. And 5 divided by 3?
1.6.
Ah, very good. Thank you. Okay, I'm feeling this side of the room is earning Starbucks. What? No, not yet.
You can't ask for it.
Okay, so now I'm just going to plot them. Now that they're all decimals, I can more easily see where to put them. So negative 0.5 falls where? Between what and what?
Negative 1 and 0.
Between negative 1 and 0. And remember, if it's not a line on my number line, I have to label it. How about 0.25? Where does that fall?
Right. 0 and then right next to the 0.
Yeah, like pretty close to the 0, right?
Yeah.
And what about 0.4?